Okay, looking at two more applications in 14.7, they talk about a rectangular figure in number 3 that has a perimeter of 52 yards, and then they want to find, with a perimeter of 52 yards, what rectangle can we create that will have the maximum area. Sometimes they word this problem in gardening or building a fence for a dog or something like that, but this is just kind of written out without the real world application here. So we know for a fact that this has a perimeter of 52, and we have a width and a length. Now normally we take width plus width, we add up the sides, or we have this formula for perimeter, 2L plus 2W equals the perimeter. Now once we know that, we can manipulate this a little bit by saying, okay, well, let's find out what L equals. So we'll subtract minus 2W. Then we have 2L equals 52 minus 2W. And then if we divide by 2, we get L is equal to 26 minus W. So what I did here is I rewrote L with 26 minus W here. Okay, so I can think about my rectangle this way. Right. Now we know to find area, we take the length times the width, or the width times the length. So I can multiply these two values here together to represent the area. Okay. So here I have the area represented. I multiplied them together, and then I moved my negative W squared up front. And then if it's easier for you to think about it in X's and Y's, we can look at it this way and do a little variable replacement or variable switch. So since we're looking for the maximum, again, we're looking for the maximum, we can think about that this is going to make a parabola that opens down, and the maximum is going to occur right there at the vertex. So we can try to find the line of symmetry by doing x equals negative b over 2a. And what we get here is we get negative 26 over negative 2, which is 13. So when, let's see, what's x stand for? X, we're substituting it for w, so the width is 13. So when the width is 13, okay, when the width is 13, what happens here? Well, we can go back to our original here. When the width is 13, we can substitute it into one of our originals here. What we get is 13 times 26 minus 13, and we get 13 times 13, and we get 169. So what's 169 represent? Well, we have it labeled right there, the area. So when the width is 13, we get a maximum area of 169. So this is feet, and this is feet squared, or actually in this problem it's yards. Yards. So this is yards, and this is yards squared. Okay. So that's maximizing the area of a rectangle. Okay, this next one here, they talk about a garden that's built up against a building, and I drew the picture here, and this time we have 2 W's plus L is equal to 180 feet of fence that this contractor wants to use. Now in this problem also they talk about that the fence is 66 feet high, which that's a really high fence. That part of the problem is not going to be used. So sometimes they throw some extra numbers into a problem that maybe you have to weed out and not use. So at this point, what I can do is I can solve for L again like I did in the last problem, and I get L is equal to 184 minus 2W. So if we think about that, I got this L is equal to 184 minus 2W. And again, we want to maximize this this problem. So we're going to say the area is equal to W times 184 minus 2W. And then I'm going to work on that a little bit and get area equals 184W minus 2W squared. Area equals negative 2W squared plus 184W. And then I'm going to do W is equal to negative B over 2A, because again, this is a parabola that opens this way and I want to find the maximum, so it opens down. So at this point, let's see, I have negative 184 over 2 times negative 2. Okay. And I find out that this is equal to 46. So I find that the width is 46. Feet, and then I can put the 46 back into the original equation, and that would tell me the area. Okay, so if I put the 46 in, I would get the area here. But in this problem, they don't ask what is the maximum area. Okay, what they ask for is what is the length. All right, so if I want to find out what the length is, I have to go back into one of my equations over here. And what I can do is I can put it right in here, or I can put it right up there. And I find out that the length equals, if I can finish this problem, that would be great, equals 92. Okay. So if they ask for the area, you would substitute it into this one and calculate. Okay. So one more problem from 14.7 coming up.